Chemistry time again. Today is empirical and molecular formula day. Okay, I spelled empirical with this crazy combination letter of M and P. Look at that. Empirical and molecular formulae. Okay. These you'll always be given some like experimental data. The reason for that is that a very common instrument for this is something called a mass spectrometer, which will give you a readout as percent of this element in the substance. So you'll start with percentages. Very occasionally, I think there were a couple like this on your chapter review, there may be one on your test. Very occasionally you'll be given a mass of substance and a mass of whatever the compound is. And in that case, if you're given a mass of the total and a mass of a part, you just find it like you would any percentage. In the same way that you find if the test was worth 80 points and you got a 46, you would just divide 46 by find your percentage, right? You divide part by total to find the percentage. That'll be the case for some of you here pretty quick. And then it's the same way if you are given masses to find empirical and molecular formula, or I hope someone's writing this down. If you are given masses, you need to change that to a percent. You don't have to, but it'll help it so that the rest of these rules follow nicely. So the first thing you do is you assume that each percentage is a mass, so like the opposite of what I just said. So the first thing you do is assume each percentage is a mass. So for instance, if we are, let's look together at the example on page, let's look together at the example on page 345. The whole page is an example. It says, empirical formula from percent composition. Methyl acetate is a solvent commonly used in some paints, inks, and adhesives. Determine the empirical formula for methyl acetate, which has the following chemical analysis. Are you ready? 48.64% carbon, 8.16% hydrogen, and 43.20% oxygen. So our given is 48.64% carbon, 8.16% hydrogen, and 43.20% oxygen. What are we trying to find? Well, let's reread the question. Determine the empirical formula for methyl acetate. What are we trying to find? Empirical formula. What's the word empirical mean, Lily? Yeah, our vocab was telling us that is the simplest whole number ratio. Empirical means that we have found it with our own senses. We have seen it with our eyes. Have found, basically. An empiricist philosophy is that nothing exists that we can't see or feel or touch or taste or whatever. And that word is related to this in that we are finding this given the basic information here. The empirical formula, but you're right. In chemistry, empirical formula is the ratio that is the simplest. We can't find any ratio with this methodology that isn't the simplest ratio. We'll talk about, after a while, we'll talk about the molecular formula, which can be not the simplest. We're trying to find, in this case, the empirical formula. So the first thing we do is we just straight up switch over all of these percentages to masses and convert each mass to moles. So we have 48.46 grams now of carbon. We convert grams of carbon to moles. What is my conversion factor of carbon? You guys were working on this on Thursday and Friday, I hope. What is the conversion factor I use for this? Someone's going to say Avogadro's number, and I'm going to throw up. Because that's not it. From mass to moles, periodic table of the elements. What is the molar mass of carbon? Let me just back up one step to make it very clear to you. Under what circumstances, what must be on one of these lines for us to use Avogadro's number? 6.02 times 10 to the 23rd. What has to be there? It's not mass in moles. What was the thing?
It would have to be moles.
Yeah, molecules or elements or particles. If we're talking about the numbers of little babies that make this up, then we use Avogadro's number. The way you can remember that is that Avogadro's number is huge, and the only time we would ever use it is if we're dealing with the smallest particles in nature, atoms, molecules, formula units, ions, those kind of things. Does that make sense? But in this case, we're not. We're talking about grams, a mass, and moles, which is a whole of things. So how many grams of carbon, mole of carbon? Oh, wow, you guys are a coven of witches and you just magically got that all at the same number that happens to be exactly right. No, where do you look? The periodic table of the freaking elements, yeah. This is a chemistry. Is that rounded? I didn't mean for it to be. That's just what I have memorized. What is it? 12.0108. I have always used 12.011. It doesn't really matter. Uh-huh. Mm-hmm. Yep, I do. Okay. What is my answer going to be? Just in units for now.
Like
no, just units.
It's actually going to be moles.
Yep.
Of
carbon. Moles of carbon. Make sure you're having. This is a little tiny example. Why you need to keep these together, because we need to be able to keep separate our. When I say these together and these separate, I mean you need to keep your unit with the element. Because we need to be able to separate what is our answer from carbon with what is our answer from hydrogen and what is our answer from oxygen. That's not the main reason I want you to do this. The main reason I want you to do this is in chapter 11, which we'll do next. But for now, it is extremely important that you keep them with, each one has an element with it. Remember, that's one of the things that's very imperative. What is this? It's going to be about 4, you're right. Because about 48 divided by about 12 is going to be about 4. What is it, though? Someone's calculator is hidden. It's in the bottom right drawer of my desk with my peanuts. Have your calculator out? For each of these calculations I'm having you do, bottom right drawer. For each of these calculations I have you do, I want 2 people to do it. One person does it and the other corroborates. Just like first one done says it, next one says I corroborate. What?
Where'd you get that calculator that has a
That's Hayes's. If you're in Chem 2, then you can have it next year. That's a special Chem 2 calculator. It's been passed on from Spencer Jones down to, actually, it belonged to Mr. Stintley initially. Yeah, do it then.
Well, I want to.
Okay.
4.
Let's have it to 4 decimal places, or 4 sig figs, because that's our lowest number here.
4.04.
I don't know. I don't have the answer.
Like rounding it up.
We should have 4.050. Yep. I corroborate. Yep. Okay, next step, well, we do the same thing with hydrogen. We do 8.16 grams of hydrogen. Now converting from grams of hydrogen to moles of hydrogen. In 1 mole of hydrogen, there are 1.0079 grams of hydrogen. Answer here. Oh, we only have 3 sig figs there. So 8.23 moles of hydrogen. What would you call this whole step? What are we doing here? Now we have 43.20 grams of oxygen. We're converting from grams of oxygen to moles of oxygen. In 1 mole of oxygen, there are 15.999 grams of oxygen. That's going to give us an amount of moles of oxygen. What do we call this whole step? What's this process? We're doing it 3 times so far. We might have to do it 20 times when we do this on our test. Yeah, we're doing unit conversion, specifically what to what? In all of them, we're converting from what to what? From grams to moles, yep. So basically, we're given a percentage used as a mass. We convert each mass to moles. So step one was assume each percentage is a mass in grams. Step 2 is convert that mass in grams to moles for each substance. What is this one?
This one would be
2.70 moles of oxygen. Corroborate?
Okay, yeah, and on the one before, she got 8.23 and I got 8.09, but they're kind of close. Maybe I'm wrong, but I thought
This looks
2.70.
okay. So now we have all of these in moles, right? We know that if there were 100 grams of this substance, why did I pick that number at random?
Well, because out of percentages.
Yeah, I automatically switched each percent to grams. So if I had 100 grams of this substance, in it would be 4 moles of carbon, about 8 moles of hydrogen, about 2.7 moles of oxygen. But what am I going to try to find? If I'm finding a formula, what does a formula actually tell us? What does a formula actually tell us? Well, give me an example of a formula real quick, and we'll talk about it afterward. No. I mean a chemical formula. What is it? Give me an example of a chemical formula.
Wouldn't it be like, what's going on, like sugar? It's like
Yeah, what is it? I don't know. I wish someone would tell me because I've been asking for a while.
6. I know 12, like 6.
That's what Payne was trying to get.
Yeah.
C6H12O6. What does this tell us about this substance?
6 carbon, 12 hydrogen, 6.
Put another way, it tells us for every 6 carbons, there are 12 hydrogens and 6 oxygens. That is telling us what mathematically about this. Yeah, I like that, but I like something else better. It's telling us there, yep, tell the ratio. And so when I'm finding empirical formula, what I'm really finding here is a mathematical ratio. How am I going to find the mathematical ratio of these homies? What's the good way to find a mathematical ratio? What mathematical operation do we do to find ratios? If I want to find the ratio of boys to girls in this room, no, which one? All of them, so which one is it? Okay, now so far there are 3 on the table right this second. We've counted subtraction out. It's not subtraction. Get him out of here. No, but if I want to find the ratio of females to males in this room, how many females are there?
4.
You guys have a misconception about me. There are 4 females in this room. How many males are there in this room? 1. So I want to find the ratio of females to males. I would say I would do what? 4 divided by 1. Right? 4 to 1 is the ratio. So to find the ratio of carbon to hydrogen, or carbon to oxygen, but what I really want is the fundamental ratio for all of them. So what I need to do is divide by the lowest. Are you with me so far? Divide by the lowest. Is this right? Okay. Well, no, but she's right. Why would you ever have to do this? Under what circumstances would you need to find the formula given a percentage of a compound? No, yes, that, but not just that. Are there jobs where this would happen? Yes. Is not just medicine, but what else? You've seen it on television. Specifically, I'm thinking about CSI. The thing I was talking about, the tool I was thinking about is called a mass spectrometer. And what it does is you shove in someone's boot dirt or something from the crime scene, and it says, this is the ratio of chemical substances. It has a little chart, and it has common chemical elements, and it has a little peak that tells you the percentage of each one in that. So the readout just spits out these things. And it's your job, investigator, to find out what the actual stuff it is. No one cares if the boot dirt is made out of 25% silicon and 13% oxygen, et cetera, et cetera. What they care about is, this was the phyllosilicate mineral whatever, and it tells us that the perpetrator was at the Cinex at 4 o'clock in the morning or whatever. So this is a useful thing. There's a tool that spits out this information. Tell something goes wrong. That's actually what it does. Anyway, so the ratio, to find the ratio of all these things together, we're going to divide by the small, right? So 4.050 moles of carbon divided by, the smallest one was 2.70. We're going to have 8.09 moles of hydrogen divided by 2.70. And we're going to have 2.70 moles of oxygen divided by 2.70. Well, this one's easy. What's 2.7 moles of oxygen divided by 2.7 moles? 1. Okay?
So how come on the bottom we put moles of carbon for
You could
moles
put
of oxygen?
you could put moles of oxygen in all of them, but I did that so that they would drop out.
Okay.
The moles still need to drop out. And by that I mean reduce to 1. Anyway, someone math it up, please. Let's review the step while someone's mathing it up.
So we're gonna
Step, yep, assume each percentage is a mass. The second step is convert each mass to moles. The third step is find the ratio by each amount of moles by the smallest amount of moles. Part. Assume each percentage is a mass. Convert each mass to moles. Divide each number of moles by the smallest number of moles.
Okay. So this is 2.99.
Which one? When you say this, you mean?
I mean 8.09. I don't know.
This one is 2.99?
Well, it's 2.996, so if you want to
It is what then? It's 3. Yeah. We're trying to find whole numbers. Maybe these have to be whole numbers. So what we're looking for here are whole numbers or a nice fraction like you're going to get on the next one.
Should
1.5. 1.5. So you're looking for nice fractions, something like halves or thirds, maybe quarters. I haven't seen that, and I don't think it's on your test. But you're looking for either whole numbers, which would be great because then you're done, or nice fractions, like things. Because this tells us what? Can I have this? Can my formula be C1.5H3O1? No, that cannot happen.
But you can multiply to make it so.
Multiply all of them by 2. If I multiply all of them by 2, then I end up with, this one becomes 3. This one becomes, you can do this part of the math even without a calculator. 6. This one becomes 2. So what's my empirical formula and how to, well, my final step, so I had, in order again, my steps were, assume each percentage is a mass, assume each, or then find the ratio of, I skipped a step I think, convert each mass to moles, find the ratio of the moles, or divide all the moles by the lowest number of moles, make sure your answers are whole numbers, like do whatever you got to do to make the answers whole numbers, and then
And then we're going to
write out our formula. What does the 3 go with?
It goes with carbon.
Carbon, so C3. What's our 6 go with?
Hydrogen.
H6. What's our O go with? O2. Is this definitely the formula of the substance? No, this is what we call the empirical formula because, check it out, let's go back over to our glucose for a second. I'm glad whoever picked this one. What's the empirical formula of this? This is what we call the molecular formula. This is how it really do be in real life. Yeah, it's not necessarily CHO, but it's going to be the lowest ratio, like Payne had said earlier. So what's the lowest ratio of 6 to 12 to 6? So it's going to be CH2O. This is the empirical formula. So this process, the product of it, the solution to it, is the empirical formula. And if all it asked for was empirical formula, like this one did, then that's fine, you're done. Great work. So for this particular one, we're done. And conveniently, well, at least conveniently for time's sake, if it asks for the molecular formula instead, we just add one more step at the end. If it asks for the molecular formula instead, it has to give you something called the FW or molar mass. What's FW maybe stand for? I'm going to rewrite both of these because I did it kind of sloppily. FW stands for, does anyone know? No one knows. Well, we'll just leave it at that then. Now, FW is formula weight, which is synonymous with molar mass. They mean the exact same thing. If it gives us the molar mass, so for instance, say, let me do a real quick calculation here. If it told us the formula weight of this was 156 grams per mole, if they had given us this and said find the molecular formula, well, what we do is we find the molar mass of our formula. So C equals 12.011 grams per mole times 2, or sorry, times 3. H equals 1.0079 grams per mole times 6. O equals 15.999. You've seen this before, right? You remember this. Our total formula mass here, I already, the reason I was doing that calculation is so I could just have this easily, equals 78 grams per mole, about. Just as a fast one. So if we find the empirical molar mass is 78 grams per mole, and they tell us the actual molar mass is 156 grams per mole, which, by the way, there's another machine, or even the mass spectrometer that you use as a forensic investigator or a medical technician will also tell you the molar mass. But it tells you this. All I have to do is divide my given formula weight, 156 grams per mole, by my found formula weight, 78 grams per mole. And what do I find there? Well, what's 156 divided by 78? It's 2. So then what does that tell me I need to do with my empirical formula to make it to a molecular formula? So then in that case, my molecular formula, which this does not apply anymore to methyl acetate. This was the formula of methyl acetate. But anyway, this is just an example. So then I multiply my empirical formula, everything in it, by 2 to get my molecular formula. So now instead of being C3H6O2, it is C6H12O6. O4. Thank you. Last thing, what if I find that my molecular formula, or my formula weight that's given, is the same as this? What does that mean? Yeah, the empirical formula is the molecular formula. Just because they have different names doesn't mean the empirical formula can never be the molecular formula. You still have to do this step. If it asks for molecular formula, you do this step 5, Kyla? Is that what we're on? So you
it would be,
add this only if it's asking for molecular formula. So once again, the 5 steps, one of which is optional. Step 1, assume each percentage is a mass.
then you're going to,
Convert the masses to moles.
you're going to find the ratio by dividing by the lowest.
Divide all the moles by the lowest mole.
And then you're going to write your,
Write the empirical formula. And then,
if you're going to add one more step,
Yep.
you're going to take the FW
find the molar mass and divide it by, or divide it into the molar mass that was given. That will give you a whole number ratio. Multiply them all by that. Questions? Specific questions. It's too hard is not a specific question. You just need to practice this like anything else. It is, this is not difficult. The highest level mathematics in here is, well, I guess you guys had a hard time knowing what ratio was, but the actual highest level of math is multiplication or division. This is not hard math. It's just a complicated process. But if you understand what's going on at each step, why you do each step, it makes it easier to remember. Do you have questions? Do you have questions? If Mitch has questions, he can ask them another time.